The weather's not too bad.
No, it looks fine up here. Just a bit cold, I suppose.
Indeed. Hang on, I've got something interesting in front of me here. I've got a speed miscompare.
Oh. And what's it saying?
I've got 120 knots indicated on mine.
Okay, no, I've got 112 across here.
Ah, okay, so we're different. What's
Yeah,
the standby
bit of a
say?
split. That's saying 120 as well.
So standby's 120 and mine's 120.
So I'm the odd one out.
It is. What should we do with that? Ah, I wonder if that's some kind of ADC problem.
Shall I check the EOPs?
Yeah.
Right.
We might want to consider reverting ADCs.
Yeah, going through the list here, miscellaneous. There's nothing here for a miscompare, but you mentioned it, ADC.
Yeah, let's have a look for a failure.
ADC 1, okay. Drill 1315. 1315, indications possible AFCS degrade.
We didn't get that.
No ASI and VSI data on one side of the cockpit.
Well, I got mine, but we're not sure that yours is right.
No. Okay. The immediate actions are nil. The subsequent actions, reversion control panel, revert to valid ADC.
Okay, so mine's correct, so let's revert to ADC 1.
That's the switch there.
Identified.
And selecting 1. And ADC 1 we've got.
There's the caution, cancelling.
And it says continue flight in VMC.
Roger.
And with that, checklist complete.
Why don't you get on to approach and find out what the weather is, and we'll have a look
check
about
now.
to find out what our options are.
Okay. Approach Hotel Echo Lima 146, requesting the latest weather for yourself and Bannock.
Hotel Echo Lima 146 approach. I'm operating by myself at the moment. That will take a few minutes. Stand by.
Roger, 146.
Hang on, Mark, something's changed here. The standby airspeed indicator has gone down to 0.
Oh, it has, hasn't it? Yeah, that's strange.
I don't like that. It's really difficult to trust the airspeed now. Tell you what, the alternate airfield's just on the ground over there. Let's get the aircraft on the ground. Can you contact air traffic and ask them for radar vectors to visual approach?
Will do. Approach Hotel 146, we have a technical malfunction. Request radar vectors to a visual approach.
Hotel 146, roger. I'll give you radar vectors to the ILS approach runway 19. Turn left heading 360 degrees. Descend and maintain altitude 5,500 feet, Quebec November Hotel 1000.
Roger, turn left heading 360, descend 5,500 feet, QNH 1000, radar vectors VLS, runway 19, Hotel 146.
Roger, Hotel 146, keep your speed up. There's another aircraft vectoring for the ILS. Can you accept vectors to short final approach?
Roger, keep up speed and yep, we can accept the vectors, Hotel 146.
Hotel 146, roger.
Okay, Mark, that's us on base leg now. Heading is coupled with the localizer armed.
Yeah, it's a fairly steep cut, isn't it?
We're very tight in. We've been tight the whole way around. We're just about on the glide path.
Yeah.
So if we are on it or just above it as we turn on, I may well need to just decouple out and manoeuvre us down to the glide slope.
Okay. Okay, that's 10 degrees to go.
Okay, localizer should be coming live shortly.
Yep.
There we are. Localizer's captured, turning on.
Confirmed. My beam bar's live.
And beam bar live this side.
Okay.
We're just above the glide, Mark. If you call localizer established,
Will do.
I'm just going to deselect out and come down to the glide slope.
Decouple. Approach Hotel 146 becoming established at 12 miles. Rate of descent's quite high.
That's me just controlling the rate of descent to get down to the glide slope.
Okay. Yeah, I can see the glide slope coming up. And it's just about on the glide now.
Okay, glide slopes coupled. Okay, I'll
And
control that rate of
descent's quite
descent
high
now.
still, yeah.
There we go, that's taking care of that. Oh, that doesn't make sense. I'm raising the collective and the rate of descent's increasing.
Yep, and watch your speed as well. Speed's going up. Speed is increasing, rate of descent is increasing.
But I'm raising the lever and
That's
we're going down.
1500 feet a minute. Just
We're
pitch up
settling
your
the
nose.
power.
Just pitch up your nose. No, you're not. You just pitch up your nose.
I don't know what's going on, I think we're losing control.
Pull up your nose. You're
out a
going
mayday
down.
call, Mark.
Speed's too fast. Just pull up your nose. Oh, turning left. What's up now? Mayday, mayday, mayday. Hotel 146, 146, 146. Loss of control.
Hotel 146.
I can see the surface. I'm just going
Yeah,
to VMC.
just pull up your nose. Just check your speed.
Airspeed.
That's going through 170 knots,
Airspeed.
175.
Airspeed.
5,000
Airspeed.
feet a minute. Just pull up your nose.
Airspeed.
That's it. Just keep
Airspeed.
pitching nose up.
I can see the valley
Airspeed's coming
below.
back. Rate of descent is decreasing. That's good. Speed's coming back. Just need a little bit more power. You've got virtually no power on there at all. Just pull
Okay.
up some more power.
Coming back. I'm just going to the valley. We should just get below the cloud and
Okay.
then be VMC.
Just watch that speed. Rate of descent is high still. A little bit
Minimums.
more
Minimums.
power. Some more power. That's 20% and increasing now. That's good. Speed's good. We're still going down 1,500 feet a minute. Just a little bit more power on.
Okay. Just under the cloud now, Mark.
Okay.
And,
yep,
I
and
can
I've
see
got a
the
clear
airport.
gap out to the right now. Just a little bit more power.
Let's go for a visual approach. If you can ask Tower for a
Yeah.
visual approach, please.
Yeah, just pitch up your nose. That's it. A little bit more power. And Tower, Hotel 146 for a visual approach.
The scenario we've just seen was based on a real event, but we've embellished some of the elements to emphasise the training points. But the scenario begins in the cruise with an icing encounter, leading to an unreliable speed indication, which ultimately results in the crew mistrusting all of the speed information displayed in the cockpit. The crew makes a sensible decision to divert into an en route alternate airfield, where they're offered and accept a rushed approach from air traffic control. It's an unfamiliar approach, and is compounded by the fact that their autopilot configuration is unusual to the pilot flying. A mode confusion event leads to a temporary loss of control, which is recovered when the pilot flying temporarily glimpses a gap in the clouds and makes a violent diving manoeuvre to the left to recover to VMC in the valley below. One of the issues that we'd like to talk about is the decision-making process surrounding the erroneous speed indication, evidenced by a speed miscompare on the primary flight displays. The crew make a sensible decision to compare their indications with the standby ASI and deduce that the pilot monitoring's indication is erroneous. There then follows a discussion on what action to take in terms of emergency operating procedures. In this aircraft, there are no prescribed actions to be taken in the event of a speed miscompare. Yet the crew relate the erroneous speed display to the integrity of one of the air data computers and arbitrarily decide to follow the procedure based upon the total failure of one of the ADCs, an action which shapes their mental picture of the situation and which affects their subsequent decision making as further technical events occur. In fact, it's likely that the erroneous speed indication was the result of an icing problem in the pilot flying's pitot system. Well, the use of a decision-making tool such as grade or DODA, decide or foredeck would have potentially prevented an erroneous decision-making process. All of these tools are designed around the crew collecting all of the available information prior to analysing the situation and then deciding what action they need to take. But a critical and common element of all of these tools is the requirement to subsequently review what information has been considered and evaluate what action has been taken. In this situation, the subsequent loss of the standby ASI was also likely to have been the result of an icing problem in the pitot system, and a review and validation of the actions taken at this stage may well have given the crew a better understanding of the technical situation that they were handling at the time. The crew's decision to divert to the en route alternate airfield is a sensible one, but it's interesting to note that having decided to terminate the flight early, they didn't choose to communicate their perceived level of urgency to air traffic control by making a pan call. The combination of reduced air traffic control resource and another aircraft approaching at the same time led to the crew accepting a much tighter than normal approach pattern, which meant they didn't have time to review what was an unfamiliar and unplanned approach. With the benefit of hindsight, we can see that the rejection of the offer of a shortened approach procedure would have allowed the crew more time to study the peculiarities that they needed to take into account and plan their approach accordingly. Well, hang on, Mark, something's changed here. The standby airspeed indicator has gone down to 0.
No, it has, hasn't it? Yeah, that's strange.
I don't like that. It's really difficult to trust the airspeed now. Tell you what, the alternate airfield's just on the ground over there. Let's get the aircraft on the ground. Can you contact air traffic and ask them for radar vectors to
Yep.
visual approach? Mark, I think this merits a pan call if you make one.
Will do.
Pan, Hotel 146, S92, 2 persons on board.
We have a technical malfunction. Request radar vectors to a visual approach.
Hotel 146, approach, roger, Pan.
I'll give you radar vectors to the ILS approach runway 19. Turn left heading 360 degrees, descend and maintain altitude 5,500 feet. Quebec November Hotel 1000.
Turn left heading 360, descend 5,500 feet, radar vectors the ILS runway 19, Hotel 146.
Roger, Hotel 146, keep your speed up. There's another aircraft vectoring for the ILS. Can you accept vectors to short final approach?
Hotel 146 negative, would like a standard approach, please.
Hotel 146, roger, then maintain your heading.
Roger, maintaining Hotel 146. Okay, that's the basic brief. And any more points to consider?
Well, yeah, we should take the time, shouldn't we? There are a couple of points, Mark, we should look at here. There is a steep glide path angle. It's a 4-degree approach rather than a 3-degree. That's going to have an effect on our rate of descent, so we need to be aware of that. There's also a note on the chart here saying that it's appropriate aircraft and crew qualification required. And this is an airport we don't normally operate to, so perhaps we should be taking more time to consider what the threats might be. The final thing is that we've got an unusual autopilot configuration, and I'm not used to flying the aircraft in a 2Q configuration, but collective won't be coupled now because we don't trust the speed. So as I raise and lower the collective, that's going to have a direct impact on the pitch attitude of the aircraft whilst we're coupled to altitude and the glide slope.
Yeah, and
So
the speed.
we need to be sure about our strategy for dealing with that and for you to monitor what I'm doing.
Yep.
The making of a pan call doesn't imply that subsequent activity should be rushed, but it does communicate to other parties the urgency of your situation and should ensure priority handling from air traffic control. There are a couple of contributory factors to the loss of control event. Firstly, finding yourself in a situation where you're trying to capture a glide path from above will often result in an unstable flight path and should be avoided in principle. Secondly, the autopilot mode configuration that the crew had elected to use in this scenario led to a real mode confusion. Because the crew mistrust the displayed airspeed indications, they choose to configure the autopilot without using the airspeed mode, which would normally be coupled in the pitch channel. Instead, this artificially degraded configuration results in glide slope being coupled in the pitch channel and the pilot controlling speed through manual use of the collective lever. There are two areas of concern here. Firstly, any mixed mode flying, where the autopilot makes control inputs in one channel or some channels and the pilot in others, has the potential to lead to confusion, and careful briefing and monitoring is required to ensure the maintenance of safe flight path control. Secondly, any autopilot configuration which controls the aircraft in a different way to that which the pilot might use to manually fly the aircraft has the potential to confuse. In the autopilot configuration chosen for this approach, the autopilot varies pitch attitude in order to maintain the glide path, and indicated airspeed is affected as a result. The pilot flying was not used to flying in this configuration, and reverted to a control philosophy more familiar to him, which was to use the collective to control rate of descent during an approach. The mismatch between what the pilot flying sought to achieve in terms of his control input and the subsequent aircraft reaction meant that the pilot flying became saturated, ultimately confusing his high rate of descent and high forward speed as being indicative of a vortex ring state, which clearly wasn't the case here. The pilot monitoring in this scenario had previous experience of flying another aircraft type where the coupling of glide slope and pitch was routine, so there was a real mismatch in the crew's confidence levels in how the aircraft was ultimately behaving. There are 2 points relating to communication. Firstly, the pilot flying's decision to make a violent diving turn to recover to VMC following his temporary loss of control was unannounced, and the pilot monitoring had no idea of what the pilot flying's intention was, and therefore his ability to monitor was severely compromised. Secondly, there was no discussion on the pilot flying's lack of confidence in operating in this particular degraded autopilot configuration. Few monitoring targets had been set, and there had been no explicit discussion or understanding of an intervention protocol should a serious deviation from the flight path occur. Headings coupled, localizers armed.
Yeah, it's a fairly tight cut, isn't it?
It is, we're just about on the glide slope already. If it stays that way as we get onto the localizer, I may need to decouple and just come down to the glide slope.
Okay.
I'll tell you what, Mark, I'm not used to flying the aircraft in this autopilot configuration. I normally fly at 3Q, so can you keep a good watch on me, please, and make sure that my control inputs make sense and the aircraft actually doing what we want it to do?
Yeah, will do.
There's the localizer.
Yep.
Captured now, turning on.
Beam bars just live my side.
And live this side. Okay, if you could call localizer established, please, Mark. We're above the glide slope, so I'm just going to have to arm the glide, deselect out,
decouple,
and then fly manually down.
Okay.
To pick up the glide slope.
And approach Hotel 146 is becoming established at 12 miles. Yeah, rate of descent's quite high.
That's me manually controlling us. Just coming down to the glide slope, should capture shortly.
Yep. Yeah, you can see the glide moving up. And that's just about on the glide my side.
Roger.
And the glide slope's captured.
I'll control that rate of descent now.
Quite high still, yeah.
Okay. I'll raise the lever.
And just
don't know what's happening here.
Watch your speed as well.
Raising the lever and the speed's increasing, the rate of descent's increasing.
It is, yep, that's going up. Just bring up your nose
this
slightly.
Doesn't feel like we're in control.
You're pitching down too far. Just raise your nose slightly. Just raise your nose.
I don't know what's happening. I feel like I'm
I have control.
You have control.
Decouple. Bring up that nose slightly. And reduce the power. There we go. Just bring it back on. There's back on the glide. A little bit to the left. Just watching that. There we go. To get it all settled down again. A little bit nose down. It's a steep approach, but that should be about it there.
That's what I couldn't understand. The rate of descent was really high.
Okay. That's all steady now.
Roger. Thanks, Mark. A more complete strategy would ensure that the parameters to be monitored are clearly identified, in this case indicated airspeed, rate of descent and localizer and glide slope deviation. But beyond that, operators should establish where the pilot monitoring is expected to make a predefined call out when he notes that a deviation is occurring. And then beyond that, further margins which define when the pilot monitoring really needs to intervene and take control. Such protocols should avoid confusion and minimise subjective opinion as to when the pilot monitoring should intervene and take control. In effect, it's emphasising that the best strategy to getting out of trouble is to avoid getting into trouble in the first place through effective monitoring and active intervention before a serious flight path deviation occurs. So finally, training can make a big contribution in ensuring that monitoring protocols and intervention strategies are clearly understood and practiced by all our crews.